Hey gang, today we're coming at you with real numbers 1.3. Can you grab those guided notes, and we're going to start right now.
Perfect. We are talking about square roots right away. So we have 7 squared equals 49. So what 7 squared means, we learned yesterday, that's 7 caret 2 if you put that in your calculator. So 7 times 7 is 49. Perfect. So we are talking about the square root. Let's see, you can use the definition above to find the exact square roots of non-negative numbers. So non-negative, not negative. Okay, the radical symbol looks like a fancy little check mark.
Or a division sign with a little doodad on the side.
You got it. Indicates a non-negative square root, also called a principal square root. Guys, we're just going to be referring that as square root, okay? The expression under the radical symbol is called a radicand.
So the blue guy here, it's color coordinated. Wow, that's terrible. Is
All right.
the radicand. The red is the radical symbol, or you can just say the square root or the radical symbol.
So together the radical symbol and the radicand form a radical.
All together.
Got it?
Got it. All right.
So simplifying square root expressions. Here, guys, we're going to let you use your calculator, but you
What?
need to know, you need to know what we're looking for. So we are looking for the square root of 25. So essentially we're asking you what times itself gets you to 25. So I know that's a perfect square. So I would use 5 times 5 to get to 25. So the square root of 25 would be,
How do I get it?
click the, yeah.
Sorry.
So if you're on your calculator, guys, square root would be second, and then square root is right above the x squared. Can you see it?
Probably
Okay.
not.
And then 25. You get your 5. Perfect. The next one is the square root of 4 over 81. So you can break this up and you can have the square root of 4 over the square root of 81. See what Rich did there? So now you want to work the numerator, which is on top, and then you want to work the denominator.
So I know what times itself is 4, 2. What times itself is 81, 9.
Good, good.
Good. So 2/9 should be my answer.
Got it.
Yahoo for me.
Beautiful.
How can you find a square root? Find a number that you can multiply by itself to get a product that is equal to the radicand.
Okay. So now we're moving on to a chart. Okay, we're going to talk about perfect squares. So we've kind of been referring to perfect squares already. Sorry, spoiler alert there. So a square of an interior is called a perfect square. 49 is a perfect square because 7 squared is 49, like we've already said. So on the box that you have on your sheet, you need to fill in the perfect squares.
We're going to do, oops, I need a pen. So we'll start with 1 times 1 is 1.
Got it.
2 times 2 is 4.
Very
I
good.
want you to go all the way up to 12 times 12. I'm going to pause. All right, guys, you should have filled out your 2 columns with the perfect square and what it equals from 1 to 12. Your 2 charts put together should look like this. Wow.
Whoa.
There it is. It's not.
Drag her away. Drag her.
There. Okay.
Oh, there we go.
How about
Got
that?
it.
Okay. So you should have 1 through 144. These are the first 12 perfect squares.
Perfect. So in your line up above those charts, you need to write in those perfect squares. So notice how on the end we have a dot, 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 meaning there are more perfect squares than just up to 12. But these are the most common ones that you'll come in contact with, so that's why we gave them to you.
Boom. All right. If you need to pause to fill in your line, go ahead and do that now. We're moving on.
Perfect. Go ahead and flip your page over. This is probably a new concept for most of you.
No, not my gang from last year. They totally get it. Yeah, they
This is
know.
awesome.
They know it.
Okay, so we are talking about sets. A set is a well-defined collection of objects. Each object is called an element of that set. Okay? A subset is what falls underneath the main set.
So we're going to talk about sets of the real number system. The real number system is divided first into rational numbers versus irrational numbers.
Yep.
Now, rational numbers are any number that can be written as a fraction. Any number that can, be, you know what, we should have typed this in.
No.
Written as a fraction. So an irrational number, any number that cannot. I'm just going to write cannot and draw an arrow to there.
Perfect.
Okay? Integers. Integers are also rational numbers. So a subset of the real number system, one subset is a rational number. The next subset under rational numbers is integers. Integers are whole numbers
And their opposites.
and their opposites. For example, 5 and -5. Those are integers. Integers are not fractions, they're not decimals, they're not percentages. They are whole numbers and their opposites, those numbers you see on the number line. Next is whole numbers.
Number. Whole numbers start at 0 and then go up. So whole, in the middle of the word whole, there's an O, so that's what number whole numbers start at. So it's just 0, 1, 2, 3, 4, ...
Meaning it goes on forever to a Google
You got it.
or a Google +1.
Either one.
Natural.
Next is natural. Yep, so natural is a subset of whole, okay? So when I ask you to count off from 1 to 10, well, I just gave it away. When I ask you to count off, you naturally start at 1. So just think of what you naturally do in the math world, and you start at 1.
So ultimately it's any number that you can count. You can't count 0 things, so 0 is not included. So those are your subsets. I like this chart. We also have a way to remember all of these over here, and it's rocket with numbers.
Mm-hmm.
Boom. R for rational, I for integer, W for whole, N for natural.
So guys, remember that all numbers are real numbers. Then the real numbers break off into 2 categories, rational and irrational. Okay?
And then under rational are 3 other subsets.
I like to think of the rational numbers being the pretty numbers that we like to work with. Irrational numbers are kind of those ugly numbers like pi that are just long numbers that are ugly.
All right. Real number system. I like this organization a lot better. You're going to have your rational here. You're going to have your irrational here. Anything that's inside this box counts as a rational number. Notice how there's nothing else over here with irrational. Inside the inside the rational numbers we have integers.
So if you have a hard time remembering how these fall, then we had our rock, which is rational. Then we have our it, which is integers.
Then we have with for whole numbers. And then we have n
numbers for natural.
Notice how if it's a natural number, it's inside each one of these boxes. So all natural numbers are also whole, integers, and rational.
You got it.
Never irrational though. All right, let's look at classifying these.
Perfect.
Take it away, Whit.
So here's just another diagram for you guys. This one is located in your book. So we left it off of your notes, but you can go to your book and look at this chart again. It does have the examples with the word lingo as well, okay? So we are looking at these. To which subsets of the real numbers does each number belong?
Gotta name them all.
Gotta name them all. Except you don't have to name real because real applies to all of them.
Right.
Okay? So we have the number 12. We are wanting to know, where does 12 fall? So what I like to do is, okay, does that start off with an irrational number or is that a rational number?
Well, I know I can write 12 as a fraction, 12 over 1.
Okay?
So I know that it's automatically going to be on the rational side.
Perfect. So then you work your way down. So it is the R.
Rational.
Okay? Is it a positive or negative whole number?
Yes.
Yes. So it is an I.
Integer.
Yep. Is it a whole number? 0 and above?
Yes.
Is it a natural number?
I can naturally count 12 things.
You got it.
Done. So it is all of these. Rational, integer, whole, natural. For those of you who have Mrs. Purdue, none of you will. Never mind.
Skip it. But it doesn't matter, guys, if you write it natural, whole, integer, rational, or reverse.
We don't care what order it's in as long as all of them are there.
You got it.
Let's check number B.
Okay.
Negative 5.01479. Okay, it's a little scary because this is a decimal.
Right.
It's also scary because it has a negative. But guess
Right.
what? We can still classify it. Because this does not have the ... after it, I know that this is what's called a terminating decimal.
Meaning it stops.
It stops. It can be written as a fraction. So, if it can be written as a fraction,
Far's here.
Far's here, we're going to pause.
Far left, so we're back.
We're back. He needed tape. All right, here we go. We're back on number B. Negative 5.01479. I know I can write this as a fraction because it's a terminating decimal. So I know that this is also negative. So negative ultimately takes out natural
Yep.
and whole.
Yep.
So this is going to not also be an integer because it cannot be written on that number line. It's only rational. Do you agree?
Perfect. Agreed.
I got it right.
Next is the square root of 21. I'm proud of you, by the way.
Thanks.
Square root of 21. So you can refer back to your chart on the previous page and look, is 21 a perfect square?
25 is,
Okay.
and that's
Yeah,
it.
yeah.
16.
So it's between,
It's between
those two numbers.
Right. So this is going to have to be a decimal, right?
Right.
Okay.
Do you know that off the top of your head?
I don't know what the decimal is, but I do know that it is going to be a decimal because it's going to be somewhere between 4 and 5.
Right. I don't know what it is either, guys.
You want to check it?
Yeah, use your tool, okay?
Check yourself
So-
before you wreck yourself.
Couldn't have said it better myself. So you're going to type in square root of 21, and you should get, ooh, not so pretty. Okay?
God, what is that? 4.5825775695. I'm
Got it.
assuming that the calculator terminated it for me.
That's what I would think.
So I'm assuming that this is going to continue to go on forever.
Yep.
Okay, so I'm going to put that dot, dot, dot. That means it's over here. This is an irrational number. Am I right? I am.
It's good. It's like you
amazing.
teach this. It's like you teach this.
All right, gang, we're moving on. We got 3 more pages. We're going to blow through it.
Perfect.
An inequality is a mathematical sentence that compares the values of two expressions using an inequality symbol. Basically, you're greater than, less than, or you're less than or equal to, greater than, equal to. This is a review from like 3rd grade. All
It's
right.
on your sheet, guys, so you have it down. So just if
Keep
you need
going.
it again, look at it.
Here's my tip for you. Write the numbers in the same form, such as decimal form, so you can compare them. So what is an inequality that compares the numbers square root of 34 and 5 4/5? Would you please change both of these two decimals and compare them using greater than or less than? I'm going to pause to give you a moment. Go ahead and pause and write it down. All right, I know that the square root of 34, whoops, I need a pen, is 5.83095, etc., etc.
Okay, she didn't know that, guys.
Oh,
Okay, it's here.
it's right there.
All right.
I also know that 5 4/5 is 5.8. I can annex some zeros. Which one's bigger? 5.83, blah, 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 blah. So I know that I'm going to write this.
Now, guys, when you write it down to compare it, you need to write it down the way the number first appeared.
Mm-hmm.
Okay, so you're not going to write 5.83 is greater than 5.8, excuse me. You're going to write it how it originally came.
All right, next page. Graphing and ordering real numbers. We just need to put these in order, guys. We're not going to graph it. Here's what I want you to do. I want you to pause the video after I say go. I want you to change all of these to decimals, put them in order from least to greatest in their original form. Start the video when you have an answer. Okay, gang, I hope you have your answer. You should have put it in the following order. Why isn't this working
I
well?
don't know.
There it is.
Okay, so remember you have to write it in the form that you originally saw it in.
So we used all these.
Yep, so negative 4.25 is the least. We wrote it in order all the way up to square root of 9.
Awesome. All right, down at the bottom, the most convenient form for numbers to be written so that they can be compared obviously is in decimal form. The numbers, which numbers will be to the left of the 0 on the number line? Obviously the negatives. And which of the numbers is not a part of the subset of real numbers as the other 4 numbers, I can't barely read it, and negative, the square root of 3 was that. Let's move. All right. Summary. Tomorrow when you come to class, we want you to be able to answer this question with your group. Because 15 is a natural number, does that automatically mean 15 is also a whole number?
Explain.
None
okay?
of this yes or no business. You got to
Got
say
it.
why. All right. See you on the flip side.
Later.